Okay, let's go ahead and try this out. So yesterday we were talking about KB, and KB, what does KB have to deal with? Bases. So everything, when we're talking about KB, everything needs to be in terms of bases, right? What do we need in order to talk about bases most of the time? What do we need? pOH, hydroxide concentration, right? We need some sort of a base making hydroxide in a reaction. So, okay, it's, whatever, it's all good. We're gonna go ahead and dive into one of them. So this is, we're gonna use KB to get pH and pOH. That's what we want to do. All of our rules for Ka still apply for Kb with the exception of making hydroxide instead of hydronium. Okay, sure. What is the pH of a 0.3 mole per liter solution of ammonia? Okay, the first thing I need you to do is I need you to think about this for a second. We want the pH. What's really the only way we can get pH? From the pOH or hydronium ion concentration, right? Do you see how those are two different perspectives? We could get pH from a pOH, i.e. a base, or we could get pH from hydronium ion, which is an acid. Do you know what I mean? So we can approach this from two different ways, from either the acid perspective or the base perspective. Now, what is the pH of a blah solution of ammonia? Ooh, ammonia. Is ammonia a base or an acid? You said that with such confidence. Do you know? No? How could you know? I'm hearing murmurs of it's a base. Are you quite confident ammonia is a base? Yeah, because it's... That's one way of thinking about it, yeah. Something's a base if it's not an acid. Okay, all right, not all the time, but yeah, ammonia is a base. Why? Because it's in the base column. You got an acid column, it's in the base column, so it's a base. It's a base because it can accept a proton. Now let's just take a look at we're gonna keep going, there we go, perfect. So I'm gonna look for ammonia. And keep in mind, it's not going to say ammonia anywhere over here, right? It's not going to say the base name, but it's going to say the conjugate acid of it, right? Okay, cool. So we see that it's a base. Is ammonia a strong base or a weak base? Strong? Weak? Weak? Strong? Strong? Weak. Strong? Strong? Weak. What is a strong base? How do we define a strong base?
It's lower than the base.
Yeah, it's lower, right? Okay. So something like cyanide, the cyanide ion is a stronger base than the hypochlorite ion. Would you agree?
Yes.
So okay, so this one's stronger than that one, and this one's stronger than that one, and that one's stronger than that one. But what is a strong base? How do we define a strong base? A strong base is an ionic hydroxide. Hydroxide is the only strong base. If you have something hydroxide, it's a strong base. If you have anything other than that, if you have phosphate, is that a strong base? No, it's a weak base. This is a weak base. Okay? The reason why that is because hydroxide, when you take hydroxide and put it in water, that's the strongest base that can exist. Anything else will not ionize 100% to make hydroxide. Will phosphate 100% turn into hydroxide? No, it won't. It'll 10% turn into hydroxide, or 1%, or 0.5%, okay? I want to be very clear. Strong base, the only strong base, okay? Everything else in between, weak weak, weak, getting weaker. Weakest base we really care about. Anything above here, so weak we don't really care about, right? Because water's always going to react as a base before any of this crap does. Okay? Somebody had a question. Sky, you had a question.
Yeah, but didn't we like establish like 2 days ago that iron 3 hydroxide is a really strong acid?
No, we said iron 3 sulfate is not a strong acid, okay? Iron ions are a Lewis acid, but you have to ignore that right now because it's not in our curriculum, and you will learn about that later, okay? You have to assume that iron doesn't do anything. Iron ions don't do anything. We said iron 3 sulfate. That's because iron 3 sulfate will dissociate in water. The sulfate is like a super duper weak base, right? But iron ions are a relatively strong acid, so it's more acidic than it is basic. You just have to ignore that right now, okay? That's why I kind of hate that lab, because we start confusing you with other things that aren't in the curriculum. Does that kind of answer your question? Okay, good. Okay, cool. So this is a strong base. Everything else is a weak base. Everything else is a weak base because it's got a Ka. We're going to be able to find the Kb of this thing. Anyways, let's get back to reality, okay? So, ammonia. Do you know the Kb of ammonia? Yes. Is it 5.6 times 10 to the negative 10? Is this the Kb of that base? No. How do you know it's not the Kb of that base? Jaden? Because when you look at the top, the header on that column says Ka. So that must be the Ka of the conjugate acid of that base, right? So let's think about this for a second. Ammonia is a base. It will make hydroxide. Let's write that down. Ammonia will react with water to make hydroxide. And what else? Yeah, I'm gonna trip today. What else is it gonna make? NH4. Oh, positive, NH4 positive. Perfect. Good. Okay. Initially we've got 0.3 moles per liter of this. How much hydroxide is in the water before we add the ammonia? 0. How much ammonium is in the water before we add the ammonia? 0. And nobody cares about water. That's sad that I say that, but whatever. Okay, so let's try and think of this. Is there anything else you can do here? Did they give us anything about equilibrium? Equilibrium anything? Read the question. What is the pH? pH has to do with equilibrium, but it's asking us to find it of this solution of ammonia. Do you see anything about equilibrium there? No. Okay, so the only thing we can do is write plus x and minus x. Is ammonia going to be plus x or minus x? Minus x. Plus x. Plus x. So we're going to get 0.3 minus x. We're going to get x, and we're going to get x. Now how, I'm curious, how are all of these values related to each other? How are all of the equilibrium concentrations related to each other? Through a K something, right? Through a K anything. But this happens to be a base, so we call it Kb, right? Do you know what the Kb of ammonia is?
Yeah.
No. But you can find it, right? How do I get? So number 1, how do I get Kb? Do you remember? The Kb of ammonia is equal to the Ka over, the Kw over the Ka of the conjugate acid. right? The Kb of the base is equal to the Kw over the Ka of the conjugate acid. Do we know what Kw is? Yes, you do. Do you have to memorize it? No, you don't. But, I mean, it's pretty easy, right? 1 times 10 to the negative 14 over the Ka, which was 5.6. That's a worse 5 in the world. 5.6 times 10 to the was it negative 10? Is that even the Ka? Am I crazy? Woo! Times 10 to the negative 10. I was losing my mind. Okay, what's this going to be? It's going to be 1.8 times 10 to the negative 5. I think. Is that pretty close? 1.785, sure. 1.785, right? Taking two extra digits times 10 to the negative 5. Perfect. Hey, we know what Kb is now. Now that we know what Kb is, now we can solve this using our approximation rule, right? Right? So let's do that. Number 2. We know that the Kb for this particular reaction, K something is always products over reactants. So products x squared over reactants, 0.3 minus x. Now what can we approximate this to be, Jaden?
X squared over 0.3.
Yeah, just x squared over 0.3, right? So if you have $300 million and you spend $5, you still kind of have $300 million. So another way of saying this is x is equal to the square root, right? We've rearranged this 4 or 5 times already. It's equal to the Kb, which is 1.785 times 10 to the negative 5 times 0.3. And that I've got no clue what that is. Goodness gracious. Square root answer equals. Did you get 2.314 blah 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 times 10 to the negative 3? Ish? Yeah, good. Okay, what is that? That's the hydroxide concentration, because this is a base, right? We're making hydroxide. So that's the hydroxide concentration. Moles per liter. Good. So from hydroxide, what can we get? pOH. So this is number 3. pOH is negative log of that. I'm not even going to write that down. Negative log of that. 2.6356, blah, 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 blah. And pOH is 14 minus that. 11.3643, blah, 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 blah. So what should I round my answer to be? 11.36. Good. 11.36 is what my answer is going to be. Oh, it's right there. Oh. Woo. Okay, okay. So let's recap just for a second, just for a really quick second. Let's recap. If you have no idea what to do, if you got absolutely no clue, if it says predict the pH of a solution, then you have to take your thing and react it with water. Now, if it's an acid, you're going to make hydronium. If it's a base, you're going to make hydroxide. Now, for acids, everything has to be in terms of acids, right? So Ka would be fine. You're making hydronium. You're going to get pH, all that stuff. That's good to go, okay? If it's a base, Well, you need to put in the work and you need to find the KV, right? Nobody cares about bases. Bases are the redheaded stepchild of the chemistry family. Nobody cares about bases, okay? So we don't list base values. You gotta find it, you gotta put in the work. So you find your base value, you're making hydroxide, you find your pOH, then you can finally get to the answer we care about, which is pH, right? Bring it back in terms of acids. Hopefully that's okay. Anybody have any questions about that? JC.
For like the final answer, would you just ignore like the number in the actual question has 3 significant digits, or would you do it?
Oh my goodness, you're that's a little bit complicated. It's just a little bit complicated because is this the only piece of information you use to solve the puzzle? No, you use this, and what else did you use? The Ka. So that's got 3 digits and that's got 2 digits, and so our final answer needs to be 2 digits. Hopefully that's okay.
Oh yeah, pH is weird.
Yeah, pH is weird, right? Remember, what does the 11 out in front here mean? It just means that's how many zeros are in front of your actual significant digits for hydronium, right? pH, hydronium. So if I were to write the concentration of hydronium, I would go 0.00000000000 and then some significant digit. That's really what the 11 means. So the 11 isn't significant. Everything else is after the decimal is significant. That's what the rule means. So there's another problem here with an answer if you wanted to, okay. And then there's diploma questions, and then there's practice questions. But what I want you to do is I want you to spend about a half an hour. So let's say 25 minutes, let's say at 11:20 to 11:25. All the way up until then, we're going to be working on the assignment that I handed out yesterday, or at least gave you the opportunity to work on yesterday. Did anybody not get the assignment from yesterday? Sorry, I just dropped that. I don't know why. I don't know.